Hello everyone, I am Isur Bandare and today I am going to give presentation on the planning and operational aspects of microgrid embedded by hybrid and renewable energy resources. Okay, let's get started with the presentation. The contents are mainly divided into 5 parts: introduction, literature review, design, research question, and the conclusion. Okay, let's get started with the introduction. As the name only suggests, microgrid is a small power generating station which is basically located near the consumers. It is a low or medium voltage power generating station compared to the bigger one in the past, which used to say deliver power to the hundreds and thousands of houses and the industrial plants. So this concept is basically developed for the proper utilization of the renewable energy resources like the wind energy, biofuel cells, solar energy, and various other renewable energy sources, as the non-renewable energy resources are going to get finished in the near future. So in this system, the energy sources from various backgrounds are put together to form a single compact system. Due to the implementation of various energy resources from the different background, the proper planning and control of the system is very important. So it's a challenge to operate the system. So the second topic of my presentation is a literature review. In this, I have come across with the idea of autonomous control of microgrid. Okay, as the name only suggests, autonomous. In this approach, each and every parts of the microgrid will act on their own autonomously. In the case of fault or any other external disturbances, so it's kind of a smart thing. So we don't have to sit in the control room and control each and every part of the microgrid manually. So it's kind of more efficient and faster than the approach the people take to control the manually. And this approach has mainly 2 components. One is static switch and the other one is micro source. And the static switch lies between the main grid and the micro sources, and it acts as a safety device for the protection of the sources and the main grid. So when any fault or any other disturbances occurs, then it will blow off and prevent the micro source and the main grid. Also, it can be used in the case of islander operation, in which the grid and the micro source acts autonomously. As you can see from the diagram, the sources of power are located in parallel with each other. So if any fault occurs in one of the power sources, then it will not affect the operation of the other power sources. They will continue operating, so they are connected in parallel for the safety reason. And in the literature review, it is very important to note that the flow of information between the players, I mean the components of the microgrid, should be very effective. Otherwise, there will be no communication between each and individual parts, and it will hamper the overall performance of the system. So there should be very fast and effective communication between the system, and the same goes for the power flow. And the flow of power between the various components of the system will be controlled by the power electronics devices. And it is very important to note that each and every components we use have to be very effective and very fast, so that we can increase the efficiency of the microgrid system. Power quality and reliability should be taken into mind, because in this today's all the digital instrument we use are very power sensitive, so the power has to be very accurate and very smooth. Uh, that is why in the microgrid there are so many challenges we have to come across with for the efficient operation of the whole system. And let's go with the design. In the design, I have come across with the idea of two kinds of operation of the microgrid. One will be islander, and other one will be the grid connection. In the islander mode, the microgrid will disconnect itself from the main source, main station, main power grid, and it will act on its own. So it starts supplying power to the houses through the power it only generates. It won't take help from the main grid or the main line. While in designing the microgrid, it is very important to find the size of the battery effectively, so that we have to record all the power demand and supply, and we have to come across with a very suitable solution to size the battery and to produce the power in such a way that it meets the demands, and we want to generate more power, because it's kind of lost while we try to store the whole power. So the design has to be done wisely in terms of the battery, or in terms of the components, in terms of the supply line. Each and everything has to be done in a perfect way, so that we can minimize the cost. Okay, let's go to this first question. So are we be finally able to put this new approach into the practical or not, is the main question. Since this approach is more expensive, it might be the negative factor first for most of the consumers, and it's more challenging to operate than the traditional approach. So this is the main question, and we have to come across with the idea which will help us to make this system more cheaper than the traditional approach. Each and every aspect of the microgrid has to be cheap, and the power in generators has to be reliable and suitable, and it has to meet the demand of the people in the cost they can afford. So the cost is also a very important factor, and the main question remains is we have to make the system pretty cheap no matter what. And finally the conclusion is, despite so many challenges in the concept of microgrid, it is practicable. We can make this system practical through more research and through more practical approach. So so we have to think about the environment, not about the money, because we have to get worried about our future generation people, because if we use the fossil fuels in other, then it will have detrimental effects on the environment, and it's not going to be good for the long run. So despite this system is more complex and more costly, we have to go through this system and put this system into the practical life, and has to cope with this. So that's it for today. If you have any question, then don't hesitate to ask. Thank you for today.